Our next talk is going to be from Josh Justice from Big Nerd Ranch. His talk will be on modifiable software systems, Smalltalk and HyperCard.
Great, thanks. I'm always nervous if my hookup is right, so someone tell me in Discord if you can hear me okay.
I can hear you.
Oh, great. Live feedback is great as well. Sharing screen. All right, let's get going. All right, well, thanks so much, everyone, for giving me a chance to speak with you. This slide link here is going to go off the screen, but it's in the Discord if you want to follow it along. So I started looking into Smalltalk. I work in the industry as a professional software developer. I wanted to look into Smalltalk to learn about the foundations of dynamically typed object-oriented programming languages. And as I started looking into this, I found that dynamic in the Smalltalk world means much more than it does in other dynamic languages. It means you can inspect the state of running objects and send messages to them. It means the source for every class is available for inspection. And it means you can modify or extend a class from within the system and it affects the live environment. As I looked into this, I was reminded of a system that I used growing up, HyperCard, and some interesting similarities. The fact that you can send messages actively to the current card that you're on, just as a user. The fact that UI and scripts are all available for inspection, and the fact that you can modify a UI or element or script from within the system for immediate effect. And so all of a sudden it occurred to me, the thing that most of y'all are already aware of and researching in, the concept of user-modifiable software. I'm using this term in this presentation to refer to any software where the user can inspect and modify in this, the software in the same environment that they run it in. And when I saw this pattern, I wanted to dig deeper and find out more. I had questions to answer. I was really curious about the background that's led us to this point of computing history. How did these two different user-modifiable systems emerge? What was the motivation behind creating them? What properties did they have that made them work this way? And what challenges did they run into? And what insights can we gain from them to apply to new user-modifiable systems like the ones a lot of y'all are working on today? I'm not in academia, but luckily I work at a consultancy that's in support of learning, Big Nerd Ranch. It's a teaching organization as well, and so they gave me some time to look into these questions. And I was able to do a lot of research and reading on primary sources. And I wrote up the results and shared them at this website, user-modifiable.software. And I'd encourage any of y'all to check it out, whether it's the quotes and excerpts in there or just the links to the original sources. I think you'll find a lot that is interesting and inspiring for the kind of things that y'all are working on. For today's talk, what I want to share out of here is 7 insights that I found about user-modifiable software, things that happen that we can learn from Smalltalk and from HyperCard that can apply to systems that we're trying to work on today. Number 1, think outside the box. Smalltalk and HyperCard took significantly different approaches to creating user-modifiable platforms. So let's contrast them for a second. In Smalltalk, you start with the code. You're always sending a message to an object, and that's where the UI and anything else that you need comes from. In HyperCard, you start with the UI. You're dragging and dropping, you're putting buttons and fields and graphics together, and then you start adding code on top of that. So it's different. In Smalltalk, there's an intentional choice to have no barriers. And so, the Smalltalk source for every level of the system, as far down as you want to go, is available for you to inspect and modify. In HyperCard, there's an intentional design choice to have user levels so that as a user, you can indicate, oh, like I just want to use a stack right now. I don't want to change anything. Oh, no, I'd like to author some software here, but I don't want to write the scripts yet. Oh, now I do want to write the scripts, and you can choose that level intentionally. Most of Smalltalk is written in itself, and so the Smalltalk code is there. HyperCard was written in Pascal and compiled down to machine code, and so unlike Smalltalk, you couldn't dive into how HyperCard itself was implemented to make changes. There was a hard boundary there. So there are many ways a user-modifiable system can work. And so a lot of the systems we've seen and we'll see later today are different again from both of these. And we don't need to feel constrained to be one way to approach this new research on user-modifiable software. Number 2, focus on a vision. These systems were driven by simple visions, not detailed upfront designs. The vision often quoted in early HyperCard talks and media was the software erector set. I am just old enough to be familiar with Erector as a line of toys, but in the last couple of decades, more typically what you'll hear about HyperCard is that it's software Legos, small pre-built pieces that you assemble together to build something bigger more easily than you could if you started from scratch. So that's one vision for HyperCard. Another vision that Bill Atkinson, the creator of HyperCard, referred to was, what's the cleanest, simplest set of tools that will empower a lot of different things? And what he found at the time was that graphics, text, and buttons were the 3 types of pieces. With those 3 things, you could create a lot more, and adding another dozen or 2 dozen or 3 dozen types of user interface widgets didn't really add much. This was the smallest, simplest set of tools, and that guided the design of HyperCard. Dan Ingalls wrote a document, Design Principles Behind Smalltalk, that talks a lot about the vision of Smalltalk. And I've got a little video thing here that's getting in my way. There we go. The purpose of the Smalltalk project is to provide computer support for the creative spirit in everyone. It's a big picture vision statement about Smalltalk. And then he says, if a system is to serve the creative spirit, it must be entirely comprehensible to a single individual. Any barrier that exists between the user and some part of the system will eventually be a barrier to creative expression. So this gives a reason behind that philosophy of no barriers, and you can see how a lot of aspects of Smalltalk fall out of that vision. Another vision statement comes from an interview that Ted Kaler was kind enough to do with me over email, and that's posted in its entirety on the User-Modifiable software website, so I'd encourage you to check it out. Ted has a really unique perspective as someone who worked on building both Smalltalk and then HyperCard. And he said, as far as referring to Smalltalk, we were devoted to letting users see their code better and more simply. Vision statement. One example he gave of how this worked out was, we avoided putting code in files so the user would not have to think about or manage files. It's such a simple statement for something that's very much a paradigm shift from most conventional software development. And yet when you read Alan Kay, Ted Kaler, Dan Ingalls, Adele Goldberg, they mostly talk about Smalltalk's innovations in this way. There wasn't a big struggle to overcome conventional software development thinking. They just followed the vision, and a lot of these innovative properties of Smalltalk fell out. This is not to minimize their innovation, but just to say that their innovation was applied in following through on a vision. So following a simple vision can yield better results than following a detailed plan. Vision more so than any particular implementation. Number 3, eat your own dog food. These systems grew in feature sets as their creators used them for their own work. One of the biggest innovations of Smalltalk was in the area of development tooling. And so the developers of Smalltalk were building tooling to help them to continue to build Smalltalk. Ted gives examples here of the code browser to let users see the classes and methods, overlapping windows to let users see more code, putting editing commands where the user was working via pop-up menus. So they were aiding their own development work. In HyperCard, the HyperCard help stack was a great instance of dog fooding. So Ted writes, development of HyperCard was partly driven by the requirements of the HyperCard help stack, which my wife, Carol Kaler, was making. She needed an unchanging background for a group of cards. She needed multiple backgrounds in a stack. She needed scripting to make buttons navigate between cards. She needed scripts to show what each paint tool can do. And so the needs of creating this help stack in HyperCard itself drove the HyperCard features forward. So eat your own dog food, make your system practically useful for you. Dog fooding is a great reality check because it helps us to see that while our systems may be theoretically interesting, they may not yet have gotten to the point where they're practically useful. And focusing on that can bring new interesting innovations on the theory level as well. Number 4, open source it. One reason that Smalltalk evolved and HyperCard died is the availability of the source code. The situation of HyperCard was pretty straightforward. It was commercial software and it was discontinued by its manufacturer. And because the source is not available, making a successor to HyperCard, which a number of people have tried, requires a rewrite. So it's a lot more effort. By contrast, if you look at Squeak, which is a Smalltalk open source implementation, Gilad Bracha, who's presenting later today at this workshop, wrote in an article, the Smalltalk compilers, tools, and libraries were provided in source form. Only the VMs were closed source. So they were very close to having an open source Smalltalk. All they had to do is figure out the VM. So what happened there, Dan Ingalls writes about in the history of Squeak. The Blue Book, an early book on Smalltalk, contains a Smalltalk description of the virtual machine. So they had source code there. And all they needed to do was to write a translator to translate Smalltalk to C. And then they were able to get a VM that was written in C and portable across platforms. And that's how they were able to bootstrap Squeak, an open source Smalltalk that's been able to be evolved and forked since then. So one way to ensure user-modifiable software stays available to users is to open source it. User-modifiable software is not always seen as the big moneymaker that corporations would like, and so it can be deprioritized and downsizing. So open source ensures that the platforms we create will stay available. Number 5, put it out into the world. The reason we know about these systems is because they took steps to get into businesses and consumers' hands. So here's a quote from Bill Atkinson about why he sold HyperCard to Apple. It was an exchange medium. You want people to be sharing stuff. They all have to have the software that it takes to at least play it, but hopefully to be able to author it also. So I worked out an arrangement with Apple that it would be bundled free, be in the box with every Mac. Adele Goldberg writes about founding Park Place Systems to move Smalltalk towards commercial software development. She writes, I knew we had something important that met the goal of empowering people, but we didn't understand enough about what this did to empower people, and we really needed to learn. And the only way was just to get out there commercially. This is just such a really interesting, unique insight. The goal was learning, and the means to that end was commercial release. So I would suggest that it would be a contradiction for any of us to say Smalltalk and or HyperCard are important, and also the only thing that matters is research. And the reason that I'd say that is we've seen that the reason that Smalltalk and HyperCard had the impact they did and are known by us to the degree that they are is because they were put out there, sent out to users and to businesses. And so there's an impact to getting things out there. One way to increase your system's impact is getting your system into consumers or businesses' hands. Don't just leave that as an exercise for the reader. At the same time, it doesn't necessarily need to be you yourself who's putting it out there. But if somebody else takes your work and tries to put it out there to a broader audience, support them. Number 6, get it in the box. And here's what I mean by that. Betancourt writes in the X-Talk interviews about HyperCard, what made HyperCard the ubiquitous product it was in the early 90s was the fact that it was included free with every Macintosh sold. So anybody could use it to create something and then share their creation with somebody else with the confidence that the other person would be able to run it. So that was the case in that day. What is the box today? Let me ask it another way. What is available on every computing device without requiring users to take any action, purchase or download? I would argue that it's the web. And however you feel about specifics of web technologies, it's immediately available to users and really serves a strong purpose in getting our software into users' hands and lowering barriers. So I would encourage us all to find ways to make the system immediately available to users. Final point, appreciate spin-offs. Some of the biggest impacts these systems had are the other systems they inspired. In fact, HyperCard is a kind of successor to Smalltalk. Ted writes, HyperCard evolved a lot during its development, and Alan Kay was advising Bill Atkinson. Bill had very clear goals for HyperCard, but Alan and I did try to push it in certain directions. Alan and I argued for generalized objects and classes, but Bill wanted to keep it very concrete. He was right. So HyperCard had somewhat of a different vision, and yet Ted appreciates the evolution that it brought about. The web is also a successor to HyperCard. Here's screenshots of 2 early web browsers. On the left, Viola www, who the author explicitly credits HyperCard and the HyperCard user interface for inspiring how he built the user interface. And Mosaic, of course, very well known as a foundational web browser, they also credit HyperCard as inspiration for the user interface. Bill Atkinson points out that HyperCard was always an authoring environment and not just a browser. And so there's a difference there. It's not a perfect successor to HyperCard, but it is a very large impact. Finally, there's examples out in the world of web IDEs that take the web further. Here's a screenshot of one called Replit. Code Sandbox and Glitch are 2 other web IDEs that put your full development environment in the browser so it's accessible from any device and provide facilities for users to edit and tweak and remix and fork existing projects. It's not a perfect user-modifiable system because there's still a run versus build distinction, but it's a step in that direction. So the biggest impact your system may have may be inspiring another system in the future. So these are the principles that I found and that I'd recommend. Think outside the box, focus on a vision, eat your own dog food, open source it, put it out into the world, get it in the box, and appreciate spin-offs. I've been encouraged already in the presentations today to hear some of these things coming up. And so whether this is a reminder, a pointer to a point that you haven't thought of, or giving historical background behind the reason to prioritize these things, I think these principles will help increase the impact of our systems and our research. So thank you all so much. And what questions do you have?
Thanks, Josh. We have time for a few questions. I have a question for you. I was wondering, Josh, what you, how you feel like Smalltalk and HyperCard impact the way you see programming now.
Sorry, I had a little trouble hearing with the echo in the room. Could you repeat that question?
Sorry, can you say that again?
I was just saying I had a little trouble hearing your question. Could you repeat it one more time?
My question is, My question is how you think Smalltalk and HyperCard like impact the way you see your own practice now of programming. You mentioned you were a professional programmer.
Yeah, thanks for asking that. I believe that HyperCard has made me incurably averse to unnecessary complexity. That was a complex way to say it. It was not intentional. HyperCard gave me a sense of how to express code at a very high level. And so when I see systems where you have to write at a low level of abstraction and I don't see benefit from it, I get very frustrated by that. And so that's, I think, what led me to an interest in dynamic languages. And I would say object-oriented languages. Not to say that it's the best solution for everything, but I think there's a lot of benefits there from a developer experience perspective. And so coming back to learn about Smalltalk and HyperCard has sort of brought me back to my roots there. So as a consultant, that in fact impacts the systems and the libraries and languages that I look for.
Thanks. Looks like we have a question from Jess.
Hey, Josh. That was a fantastic talk and awesome summary. So I share a lot of your same experience of like discovering some of the principles behind Smalltalk and HyperCard and that kind of stuff. And also what I have observed in the computing industry at large, what Adam Wiggins calls collective amnesia, of where we have just collectively forgotten our past and we keep reinventing things without like understanding the principles. And I thought one of the things that you did really well in the talk is like, you didn't just show the features of the software. You talked about how the vision and led to certain properties. The properties led to innovation, which led, in specific features. And I was wondering if you have any ideas on how we could, as an industry, get this information out there, right? Like the 25 people that are hearing this talk right now, or 35 is like a small drop in the bucket. Like how do you solve for collective amnesia?
I really wish I knew the answer to that question. The only thing that comes to mind now, and I'm going to sort of take it as a challenge to think more about that, and maybe I'll post something in Discord and get a conversation going. The only thing I can think now is just thinking about each of us at a particular point on the spectrum. So as y'all can tell, I'm not a researcher, but as a working professional consultant, my interests verge a little bit towards the learning side. And I also like to write tutorials and do learning. I created a tutorial. I was just talking in Discord about a tutorial for a UI framework for drag and drop creation in Squeak. And so I made a tutorial for that. So I'm right at that extreme. That others who on the call and in this community who are doing research for brand new things, others may be a step back that are taking some of that research and iterate on it. Others can create a company off of some of these things. And so really it's taking our passion for general computing principles and the principles of live programming and just enabling users and finding for each of our unique passions and where we are on that spectrum of industry and individual practitioner and researcher, and just doing our part to pass knowledge along to whoever our audience is, whoever is listening and whoever is interested in what we have to say. But I wish I had a much better answer than that.
That's great.
Looks like we have time for like one more question. Yeah, Clemens.
Hi, Josh. Thanks for a great talk. So you come from the industry side. So where in the software industry do you see the biggest potential for user-modifiable software in the future?
I feel to be discouraged. The circles that I'm in, the move is very much the other direction. There's a move towards locking things down for a security standpoint. And security, certainly the state of IT security is really a disaster these days. So we need to get better at security. There's also a move towards statically typed and functional programming, which I see a lot of value in. And some of y'all, I think, can see the ways that does overlap with user-modifiable software, which would be great for me to learn from. But I think some of the static typing, it's putting a lot of safety in place, and that's one of the big benefits in the circles that I'm in. Safety, prevent crashes, and yet it adds a lot of boilerplate and a lot of impenetrability in some cases. I know I have to level up my skills. The hope might be JavaScript, I'm sorry to say. For some folks that don't prefer it, I don't prefer the language in and of itself, and yet the web platform, Apple lets it through the App Store, and now we can sideload software onto an iPhone, for example. And I think there's, potential of JavaScript and in WebAssembly, the fact that we can build other languages on top of this that get still the same, web browser dynamically loading context. So I think WebAssembly has a lot of potential for providing new ways to build on top of this platform and break us out of some of the bonds of one particular programming language.
Okay, thanks so much, Josh.
Thank you.